Present-day symmetric algorithms are very complex. The data encryption standard, or DES, is a well-known symmetric algorithm. DES is one of the most widely accepted, publicly available cryptographic systems today. It was developed by IBM in the 1970s, but was later adopted by the US government and National Bureau of Standards as an official Federal Information Processing Standard, FIPS, for the United States in 1976. It uses a 56-bit key to encrypt the 64-bit block size data. It processes 64-bit inputs into 64-bit ciphertext, and the algorithm performs 16 iterations. So how does DES work exactly? Encryption of a block of the message takes place in 16 stages or rounds. From the input key, 16 48-bit keys are generated, one for each round. In each round, 8 so-called S boxes are used. These S boxes are fixed in the specification of the standard. Using the S boxes, groups of 6 bits are mapped to groups of 4 bits. The contents of these S boxes have been determined by the US National Security Agency, the NSA. The S boxes appear to be randomly filled, but this is not the case. Recently, it has been discovered that these S boxes, determined in the 1970s, are resistant against an attack called differential cryptanalysis, which was first known in the 1990s. The block of the message is divided into 2 halves. The right half is expanded from 32 to 48 bits using another fixed table. The result is combined with the subkey for that round using the XOR operation. Using the S boxes, the 48 resulting bits are then transformed again to 32 bits, which are subsequently permutated again using yet another fixed table. The now thoroughly shuffled right half is now combined with the left half using the XOR operation. In the next round, this combination is used as the new left half. The figure you see before you should helpfully make this process a bit more clear. In the figure, the left and right halves are denotes of L0 and R0, and in subsequent rounds as L1, R1, L2, R2, and so on. The function f is responsible for all the mappings described. This secret key encryption algorithm uses a key that is 56 bits or 7 characters long. At the time, it was believed that trying out all possible keys would be impossible because computers could not possibly ever become fast enough. In 1998, the Electronic Frontier Foundation, or EFF, built a special purpose machine that could decrypt a message by trying out all possible keys in less than 3 days. The machine cost less than $250,000 and searched over 88 billion keys per second. So to summarize our learning about the data encryption standard, here's what we know. The data encryption standard is a secret key encryption scheme adopted as a standard in the US in 1977. It uses a 56-bit key, which is today considered by many to be insufficient, as it can, with moderate effort, be cracked by brute force. A variant called triple DES uses a longer key and is more secure, but has never become popular. The advanced encryption standard is expected to supersede DES as the standard encryption algorithm. Do note that DES is no longer considered secure.